All right, so today what we're going to do is we're going to look at one of the applications using probabilities, and it's something called the normal distribution. You're going to find that through this course, and then if you take year 13 stats, that there are lots of different ways that information is distributed. And one of the most common is the normal distribution. If you did an experiment enough times, and it was like a natural phenomenon, like height of certain age groups, or heights of trees, or lengths of butterflies, whatever, you would find that they would eventually, again, doing enough experiments, approximate what's called the normal distribution. So this type of distribution is really common in lots of ways. So we're going to look at some examples and what it looks like, and then we're going to learn how to use it. Now, you can use charts and tables to be able to do these, but it is much, much easier on your calculator, because with charts and tables, there are some limitations as far as what they measure. They only cut because you don't want to have a table that's 12 pages long, but your calculator can do any probability using the normal distribution. So make sure you bring that calculator every day and that you learn the keystrokes. All right? So let's just go to Education Perfect and look at some of the pieces of the normal distribution. So if you look at this particular graph, you can see this is a graph of information that is normally distributed, or generally we call it approximately normally distributed, because nothing ever comes out to be perfectly normally distributed. But if you notice, it starts off very small down here, then goes up highest right in the center, and then back down to about where you started. So you get that often called the normal curve. You might hear teachers talking about grading on a curve, and this is what they're referring to, where the majority of students would get a grade here, which would be achieved in your case, right? No, that's because that's achieved as the standard, and then some students would get merit, and a little tail up here should get excellence. Now, is that the way it usually works? No, because these tests are not normed. And if you're talking about grading on a curve, usually the instructor just adds points to the low ones and brings everybody up, right? But in a normal curve, we would be taking excellences down. So you don't want anybody to ever grade you on a curve. Literally. Yes?
With a test like that, like if people, for example, like if people in that year were doing better, would then, like the still same kind of people get excellence, they would just move up the bracket for like getting excellence?
Right. So there would be, the grade boundary for excellence would go higher. Because if you think about it, what does it tell you if everybody's getting excellence? The test was too easy. Not everybody is an excellent student, right? Okay? This is where most people should be if you're actually measuring general knowledge in the real world now. And if you looked at something, now different schools would be different. I would expect Queen Margaret not to follow this pattern. I would expect more up here. Now, but if we went through all of New Zealand, right, you can't do that with small samples. That's why you don't ever want a classroom done that way. But if you went through all of New Zealand, that's what would pretty much happen. Okay? All right. But of course, different schools, different levels of achievement, right? Okay. Well, a lot of things in nature are also turn out to look like this. And so here we are. We have the height of 10,000 garden gnomes. Anyway, so notice 10,000. It's a lot of them, right? And in order to approximate the normal curve, you have to have a lot. 10,000 is actually a pretty small number. But if you look at them, what happens here is some of them are very short, most of them are right here in the middle, and then some of them are very tall. And if you think about your own experience, is that not what happens in your class? Right? Okay? So, same idea. But again, it has to be lots of people. Now, there's some distinct features that you need to be aware of, okay, when you're dealing with these. First of all, they're very symmetrical in shape, meaning that you could pretty much fold it in half and fold one side right on top of the other. Yeah? Approximately symmetrical, never perfectly symmetrical. Most of the data occurs here in the center. If you look at these bars, the heights of these bars in the center, do you see that that's where most of the data is, right? Okay. Okay. And there's not very much at either end. So when you get to either end of the data, those taper off to almost nothing. Okay. All right, so that's the shape of the graph of this information, but we need to talk about some of the other features of it. And this only works when you're talking about continuous data. When discrete data sometimes comes out to that, but continuous data, what does it mean if it's continuous? Yeah, any value. So like your height. If you say that you're 2 meters tall, does that mean you're exactly 2 meters tall? Probably not, right? You're a little above, a little below, and that's fine. They're increments. But then there are other things, say like shoe sizes. Do shoe sizes come in every fraction? No, it's usually like 10, 10 and a half, 11, 11 and a half, right? So that's discrete data. It can only fit certain numbers. There is no number in between. So continuous data, it can be any value, is typical of the normal distribution. All right. So here's an example of a normal curve. Now this one is exactly perfect. That'll never happen to you, but you're going to see them. But you see that it's still very similar to what we just saw. If you folded it in half right there in the middle, then they would fall exactly the same on both sides. The shape is described as bell-shaped. This is often called the bell curve or normal curve. And there is only one mode, and it is always in the center of the data in a perfect world, right? And that piece of data in the middle is called the mean, right? So the average, the middle piece of data. A normal distribution is defined by two distinct pieces of information. When you have a normal curve, that piece in the center is the mean, and the symbol for mean is the Greek letter mu. It's just because it's M, mean starts with M, right? So you'll see that mu. And the standard deviation. And when you're talking about standard deviations, there are 3 standard deviations on either side of the mean. So it's divided up into equal pieces along the number line on the bottom. That does not mean that equal pieces of information exist inside each section, because this section obviously is much bigger than this section, right? And each one of those standard deviations is numbered. 1, 2, 3 on that side, 1, 2, 3 on this side, and since they're below the mean, we typically put a negative, but you don't have to. Okay? So, if I am looking at this is one standard deviation. And the symbol for standard deviation is the Greek letter sigma, just because it's an S, right? Okay. Now, every normal curve is divided into the exact same amounts. You do not need to memorize these. Okay? Your calculator will give you these amounts when you're working with these, because you're very rarely going to be looking at exactly one standard deviation. Usually it's somewhere in between. Okay? But 68.2% of the values lie within one standard deviation of the mean. So that means from the mean to this first line on this side, that's 68% of the data from either side. 95% within 2 standard deviations. So 2 standard deviations means from here to there. Right? So 68%, almost 70% of the data lies in that range there. And then finally, 99% of the data from 3 to 3. Okay? So most of the data is enclosed there. Notice that the curve doesn't stop at the end. There's always the possibility for more data, tiny amounts further on. Okay? All right. Again, don't try to memorize those values. It's not going to make any difference. But there are some values you do need to memorize when you're talking about the normal curve. Okay, so there you that. And they're doing it again. We don't care. You can have, they can be higher and they can be lower. They're not doing what I want them to do, so I'm going to draw my own. So, if you have a normal curve, now again, you don't need to memorize those values, but you do need to memorize this part. The mean is always in the middle, and there are 3 standard deviations on each side. The mean divides the data exactly in half. If you have the entire thing, that's 100% of your data. Do you agree? And if the mean divides it in half, that means that 50% of the data is on this side of the mean, and exactly 50% of the data is on that side of the mean. And those values are critical. You need to make sure that you memorize that. It's pretty easy. It's very straightforward. Half on one side, half on the other. Right? So that means that you could divide that again in half, and that's 25% here and 25% there. Make sense? But it's not going to fall on one of the standard deviations when you do that 25%. Okay? But just be aware that you can divide up the data into more pieces. The whole thing is how many percent? 100. On either side of the mean, there is 50, always. Okay? And it never varies. It will always be exactly 50% across the mean. And that's going to be really important for you when you're answering questions about these. Okay? So let's just look at some things. Right? It's also known as the median. It's the one in the which is always the data point in the center. I hate it when they throw little doodads in there. So the 2 parameters of normal distribution are the mean and the what, though? Standard deviation. There you go. Okay? All right. Who cares? You're never going to have to know those numbers because your calculator is going to do the math for you. Rank the normal distributions from smallest to largest according to their mean. Okay? So, depending on where the mean is, look at the mean is way over to the right. That means that's a bigger number, further to the right. Okay? But we also have height to consider. So how many pieces of data? So which one do they want here? According to their mean. We'll just cheat. So they're talking about how high the mean is. So even though this is a bigger value to the right, they're talking about how the mean is measured by the height of it. So you can see compared to the heights, B is higher. But all of these are still examples of the normal distribution. So they can be different shapes. Okay? So let's look at an example here, and they're going to use exactly one standard deviation, so you can do this without having to know the new calculator keystrokes. Right now, we're just going to stick with these. Possums differ in their susceptibility to the poison 1080. The amount of 1080 needed to kill a possum, which is the lethal dose, in milligrams per body weight, is normally distributed with a mean of 0.8 and a standard deviation of 0.2. So, if it says normally distributed, you automatically think about that normal curve. Yes?
Is there a difference between standard deviation and standard distribution?
No. Yeah. Yeah, that's an odd. But it's still abbreviated sigma, so it's still going to be the same. All right. So normally distributed with a mean. So that means the number right in the center is 0.8. Yeah? And as we go to the right, we're going to have how many standard deviations? And to the left, there are also what? 3. Now remember, that thing along the bottom is a number line. So it behaves just like any other number line. As you go to the right, the numbers get what? Bigger. And as you go to the left, the numbers are smaller, right? So when you're building one of these, your standard deviation is going to build your, so in other words, you're going to add it as you go to the right, but you're going to subtract it as you go to the left. Okay? Get your calculators out because I'm not doing any math. Y'all are. So 0.8, and our standard deviation is 0.2. So we're going to add 0.2 to the mean, and which gives us 1.0 there, and then add again, because here's another standard deviation, so add one more, that gives you 1.2. Here's another one, add one more, that gives you 1.4.
Can you assume that, like, it's like evenly, because you know how you're saying how
They're always evenly distributed. The standard deviations are equally along the number line, because we're not talking about the heights of the curved line at the top. We're just talking about filling in the number line at the bottom, and those are always exactly even. Okay? All right, so now let's drop the other way. So we got 0.6, 0.4, 0.2. I didn't need your calculators because those were easy numbers this time, but they won't always be. Usually they are very ugly numbers. Okay? Yes?
This could be a silly question.
No.
If you're talking about the data after the third standard deviation, what would you call that? Do you know
Well, this one is this area here, for example,
Yeah.
at the bottom, that is 3 standard deviations that's below the mean.
Okay.
So it's
So you-
so it's to the left of that. Okay? Yeah. So the data here, from there to there, that's 1 standard deviation below the mean. Okay? Good question. Not a bad question at all. All right. Okay. So now we have our distribution. Hopefully you drew this, because you know when I push this button, it's going to go away, and we have to answer questions about these.
Wait, I have
Okay? Yes.
so
All right. Another piece of information that you must understand and must grasp is that you're going to hear things called the standard normal distribution and just a normal distribution. We focus? Listen. So, a normal distribution is a distribution that has a mean and all of the standard deviations with their proper numbers. A standard normal distribution has a mean of 0, and then it's just 1, 2, 3, and -1, -2, and -3. So that's the one I drew as an example, where the mean is always 0, and then the standard deviations are 1, 2, 3. And again, you're not going to quite understand why you would want to convert to that, because it doesn't make any sense. You can't answer things with it. But when we start working these problems, you're going to need to understand, because you're going to be asked to use the standard normal distribution. So if I say just normal distribution, that's whatever the numbers are from the problem, right? But a standard normal distribution is this basic one with, what does it mean? Always 0, and then it goes up and down 1 standard deviation. Okay? So watch that terminology. Standard normal distribution means that one where it's just 0 and then the numbers. Okay? All right. And again, you won't understand why that is so important at this particular time, but it is. Okay? All right. So what it'll allow us to do is later it'll allow us to work backwards. And many, many, many of these problems will make you work backwards, so you're going to have it. Don't worry about z-tables. We're not interested in that, because we're not going to be using the z-tables. We're going to be using our calculator to do these. And Education Perfect will not tell you about the calculator use, so we'll go through a lesson for that on our own. Okay. All right. So we've had an introduction to the normal distribution. Now let's talk about how we're going to use it and how we can use the calculator to find these for you. And again, you must remember these calculator keystrokes. Now we're not going to use z-scores to do this. We're going to calculate them. And we're not going to calculate them by standardizing this. Just remember that it is a standard normal distribution. We're going to do this in a completely different way than they're going to be describing. So you need to pay close attention to what we need to work on. So we're going to use the normal distribution for these. The only time we're going to use the standard normal distribution is when we're working backward, and we'll do that in a bit later, but not today. Okay? So let's look at finding some distributions. Again, don't worry about that equation. That's going to be later. Okay, they're still describing it, so don't worry about it. Okay. All right, here we go. So, but we can answer this one, and we're going to talk about the calculator keystrokes that you're going to need to use in order to be able to answer these without having to use z-scores in the table. Okay? All right. So, the weight of a newborn puppy is normally distributed. That means automatically draw your normal curve. And if you don't draw the curve and use it when you're working with these, it is quite possible that they'll count it wrong, right? And besides that, it's a lot more difficult to find out which area. Are you talking about above the mean, below the mean, what's going on? Because they're not going to tell you above the mean. They're just going to give you a value. And you need to find out, is it above the mean, below the mean, etc. Okay? Or between two values. So the weight of the newborn puppy is normally distributed. Newborn puppies have an average weight of 850 grams. Average is another way of saying the mean, and you need the units on there. It's not too bad to put them on there, though, because if you answer the question without units, it is completely wrong. So make sure you're very careful about that. With a standard deviation of 20 grams, so we can draw our normal distribution. So it's just going to go up by 20. So 870, 890, 910. Yeah? Going up on one side, down on the other. So 830, 810, 790, right? Going down 20 on both on the other direction. So now we have our normal distribution drawn. It will remain the same for all the parts of the question. It won't change. It can't change. Otherwise, you're starting over with a whole new thing. So make sure you draw it, but once you've drawn it, you get to use it for every part of the question. Do not worry about calculate the z-score of the puppy. We're not going to worry about that, because we're going to just answer questions. So do you have this written down?
Give me a second.
Come on, guys, because we need to have them written down because you need to be able to answer the questions. Okay. And again, we're not calculating a z-score. We're going to talk about using that. So here we go. Again, got this one. Let's just clear this. Let's talk about the steps that you're going to use to do this. So to find probability using the normal distribution. Okay. First, draw your normal curve. And when you draw it, label the mean and the standard deviations. So just find all the standard deviations. Make sure you put everything on there, okay? It's going to be important that you understand exactly what it is that you're looking for. Second, shade the area you are trying to find. Because the way the normal distribution works is that the area under the curve is what you're looking for. And that will tell you how much of the probability fits into that space, which is the probability for the thing that you're looking for. So you're always looking for areas here. And so if you shade the areas that you're looking for, it just makes it very clear whether you're above the mean, below the mean, because it's going to make a difference in your calculations, and how much you expect that to be. Get a general idea. Mm-hmm.
What does it say? So label. It's got
Label mu, and sigma.
How do you spell the first one?
Mu, mu.
Oh.
Mm-hmm. Okay? All right. Then you're going to go to your calculator. The calculator will do all the work for you as long as you enter everything correctly. Now remember that when you go to take this assessment, we're going to clear your calculator. And when you reset your calculator, it's going to change some things. So you need to be aware of how to get there from the very beginning. Once you start using it, it'll hold the same pattern that you have. It'll hold those values, but you have to make sure that you can get there from the very beginning. Because we cannot, after we clear your calculator, we cannot then tell you how to get to where you need to go. Okay? So be careful. So for your calculator, first, you're going to go to menu. And that's going to open up the menu you need. And as you may expect, you need the stats menu. And you can get there by just pushing 2. I would follow along if I were you guys. Come on. Yeah, on the calculator. Yeah. Yeah, follow along on your calculator so you can see, because I want you to be able to see exactly what it is you're going to be looking at. Okay? So go to menu. It brings up that whole tape, that whole bunch of boxes, right? Okay. So it should be a whole bunch of boxes when you do the menu. Okay, so you're going to put menu, then you're going to hit stats, which is simply use the number 2. And then you're going to see it brings up a table, right? Well, at the bottom of that table, because you don't want to put anything in that table, at the bottom of the table, you're going to see a list of choices at the bottom. Do you see there's some little black squares at the bottom? What do they say?
Calculate, test, dist.
Okay, so we're doing a distribution, so you're going to hit F5, distribution. Okay? Now, there are lots of kinds of distributions. Remember, I said that you're going to learn about many, many more of them next year. This year, we're going to concentrate only on this one. So we want to choose, what do you think? Normal. Okay? Now, all right, so the normal distribution, or F1. Okay? Now, once you hit normal distribution, you're going to have some more choices to make. Okay. You're going to see it has NPD, NCD, or inverse normal, INV normal. We're going to use 2 of these in this course. But if you're just looking for probabilities, what you're going to do is you're going to use the NCD. So F2. Okay. Once you do that, you're going to be given 2 more options, either list or variable. You must be in variable. Because remember, we're not using that list of values. We're using X, some unknown, our variable. Okay? So you have to change that to variable. So you're just going to hit F2 there. Okay? And then from that point, you're ready to enter values from the problem itself. Okay? And they're pretty self-explanatory. The first one you have is it asks for lower value or upper value first? Lower. So it's going to ask you for your lowest value. Now, let's just pretend I have this normal distribution. Who cares what the numbers are? And I'm looking for this space up there. Okay? Well, whatever value this is going to be your lower value. And because they told you, like in this particular instance, if you had that shading, that would tell you that this is the X value, the boundary they gave you. So they're going to give you that number. But notice that it goes on forever to the right. So the lower value in this particular instance is the one they gave you. Then we need an upper value. Well, if it goes on forever to the right, we don't know our upper value. So what we're going to do is we're just going to use 99999. 5 nines. Always. Okay. Now, you could have a situation where they do the opposite for you. So let me show you what I mean. So you have your normal curve, and we're looking for the things that are below this. So again, that's our X value, our boundary that they have to give us, no choices. But now we're going down forever to the left. So to indicate that, what we're going to do is we're just going to use negative 5/9. Okay? So negative 5/9 to indicate that we're going to the left. So do you see that if they don't give you any boundaries, then if it's to the right, you're going to use positive 5/9. To the left, you're going to use negative 5/9. And again, that's just so that you capture all the information. You could use a smaller number, but just make yourself sane. All right. Now, they could also give you both your upper and lower boundary. So they can say x is between this number and this number. So you're looking for those two. So that means I'm going to know two values. So this is my lower value, and this one was my upper value. Right? It's much more straightforward when that happens. But either way, it doesn't make that much difference. Right? Okay? Then, the next piece it asks for sigma or mu?
The sigma.
Sigma. Okay? So that's your standard deviation. And they have to give that to you from the problem. And then finally, they ask for mu, which is simply your mean. Then, just hit execute or equals. Now you may have to hit it twice. So you may have to hit it twice because it's going to give you something weird before it gives you your answer. And then it will give you the probability. Right? Okay. Well, it depends on what you put in. Okay. So you're not going to be calculating z-scores like they want you to do on the Education Perfect. You're going to be using the calculator to answer the questions instead. Right? It's very straightforward as long as you first draw your normal curve, put in your shading, so that you know exactly which piece you're looking for. Do I have an upper and lower boundary? Does it go on forever to the right, which means my upper boundary is all a bunch of 9s? Does it go forever to the left, which means my lower boundary is a bunch of negative bunch of 9s, right? Because remember that bottom thing is a number line. Okay, so let's look at some questions. Now, again, you're not going to be showing much work, which means when you're doing this, because the calculator is going to do the work for you, which means you need to draw the normal curve and do some shading on your work so that they can see that you've done something, you know what it is you're looking for. Okay? So, let's look at some of these. Here we go. The weight of the female southern brown kiwi is normally distributed. They have to say that, otherwise you cannot assume that it's a normal distribution. With a mean of 2.56 kgs and a standard deviation of 0.15 kgs. Okay? So first thing we're going to always do is start by drawing our normal curve and doing the math that we need to do to get those numbers in there. So it's 2.56. Then as we move to the right, we're just going to go up some. As we move to the left, we're going to go down by these amounts. So what's 2.56 plus 0.15 going to give me? 2.71 plus another one? 2.86 plus another one? 3 point what?
01, I think. This is me doing it in my brain.
Okay. Now we're going to go below. You all have calculators right in front of you guys. Come on. So then we're going to go below. So 2.56 minus 0.15 is 2.41. And minus again gives us 26, yeah. And minus another one gives us 2.11. Okay? Good. All right, so now we have our information drawn. We want to know what proportion is just another way of saying probability, of the southern kiwi weigh less than 2.3 grams. So you see why you need your numbers on your chart. Otherwise, you're not going to know where that's going to be. So we want the probability that X is less than 2.3 kgs. You still need your probability statements. You've got to have them, so make sure you're making them. Now, 2.3 is not on our chart, but here's 2.36, so that means it's in there somewhere, right? 2.3. And we want less than, which is this tail at the end, isn't it? If it's less than that. So make your mark where it is, and then make some shading. And now we're going to go to the calculator to actually do the math, right? So first, menu, stats, all that will be held in your calculator. So menu, stats, normal distribution, and normal. Make sure it's not on list. Make sure it's on variable. If you've done it with variable in the past, then it'll hold that. But again, remember, we're going to reset them for you when you go in there. So it's going to mean it's not going to be on, the default is list. You need to change it to variable. I need then a lower limit. And in this case, it's going forever to the left. So what am I going to use as my lower limit, guys? There you go. Minus and then 5 nines. Then I need an upper limit. So that's the limit on the right, which is the number they gave me, which is what? 2.3, right? And then I need a standard deviation, which again they gave me from the question. The standard deviation is 0.15. And then I need a mean, which again they gave me from the question. That's 2.56. So just plugging those in and hitting execute once or twice on this one, I've forgotten.
Wait, why is the upper 2.3?
Because 2.3 kilograms is what they want me to measure. It's the value to the right, right? So that's, again, the importance of doing the shading. So that's the right value of my shading. Yeah? Okay. All right. Anybody got a number for me?
My number doesn't look right.
Well, what is your number?
0.041518.
Okay. Can you